This coding challenge is called max sliding window. So what we need to construct is a function that accepts two arguments. So the first argument, which is this guy, it's an array of integers or numbers, and these numbers can be either positive or negative. And the second argument is an integer which represents a window size, and the output needs to be printed to the standard out, which means that, and of course we print the max integers in the current window, right? So if we visualize this, we see that if the window size is 3, we have 3 numbers inside this window, and this window is moving, right, until the end, like this. Cool. So the first output would be, for the first window, would be 9, right? We have 3 integers, and the max inside this is 9, right? And the next window is also 9. Now it's changed to 4, and the final output, so the max value for the final window is 7, right? So you can take a moment and think about how you would solve this. Then we can do this together. Cool. So one way of solving this would be to, so the brute force approach would be to iterate through all of the windows, and when we encounter window, we just go over each number and just return the max, right? So this would give us of n times w for runtime, and for space complexity it would give us of w, which represents the numbers inside this array. So this would be brute force approach, and we will see this later how it's implemented. The other solution that it's more optimal, because we could optimize not going through each of the numbers inside every sliding window. What we could do is use linked lists or double-ended queue. The Python library has DQ built in, so we'll be using that. But if we compare DQ and lists or arrays, the main difference is that when we use arrays, when we push and pop the values from the right side or the end, it's all for one operation. But when we do this on the left side or at the beginning for the list, it's all for an operation. But if we use DQ, it's constant operation, so all for 1, right? Okay, so if we look at the solution for using DQ would be just to start at the beginning, and we would just push it to our max sliding windows, right? Moving on. Now, when we encounter bigger number than what we currently have, we can just remove this number, right? Because we know, and we have our, when we are printing the values from our window, we only care about the maxes, right? Cool. Now we have 9. 9 is bigger than 2. We can remove it, and we have 9, right? Now we have the first window, and we can just output the first value inside our W. Cool. Moving on, right? We see that we have 4, and you could probably think that, yeah, we don't need to push it because it's smaller value, but the thing is that 9 will not always be in our sliding window. So when we have window which has 4, 1, 1, it's actually, it matters that we have 4 inside it, right? That's why we need to push it, right? And that's it, right? Cool. Another way of solving this would be, instead of using DQs, we could be using heap or priority queue. So we could be building max heap, right? Starting from the beginning, we would have 1, 2. So would change to having 2 and then 1 and so forth, right? 9. So the 2 is here, 9 is at the top, right? And always when we try to print the max values, the max in the max heap, the max number is its root. Cool. So let's look at the solution inside Co for all those 3. So the brute force using the DQ or using heaps. So if we have an array of values 1, 2, and let's have 1, 1, and 1. Max window. We'll pass in an array and the window size, which can be 3. So our first solution would be force. So we have an array and window size, like this. So for brute force, we'll be looping over each index, so in range starting from 0 up until so we have length A minus window size. Now because this code could easily be off by 1 error, so we need to check if this is correct. So length of this array is, so 3, it's 5, right? Minus window size, which is 3, so 5 minus 3 is 2. So we'll be looping over these 2 numbers, but we need also to loop over 1 as well. So this guy here, we need to loop over these 3 values. So we need to fix this. It's +1. Cool. So our W would be I plus window size. So we're constructing our slice, and we can just print on each iteration. We print the max value from this window size. If we clear the output and print the results of this function, what we should see is 2, 2, and 1, right, as a result. Let's do this, and we have an error, empty sequence. Yeah, of course, it should be plus. And we have 2 to 1, like this. Cool. Okay. So let's talk about, so we already talked about time space complexity, so we don't need to do this here. The next solution would be to use DQ. So for that, we need to import collections module. Construct DQ from collections. So collections, like this. Okay. The first step we need to do is construct initial max window. So let's do that. For I in range, so starting from 0 and window size. We need to first check if the containing values are smaller. So while W is not empty and the current or the last value is smaller what we currently have, which is A of I, like this, we can just pop it right off. Once we're done, we can append the index like this. And after our loop terminates, we have our first max, which we can print like W0. If we clear the output and print it, we should see 2, which is correct. Cool. And the last thing we need to do is just go for I in range, starting from window size up until the last index, which is length A. Cool. And here we'll have something similar than this. So we're removing everything that is smaller, we're appending, and before we print, we need to check while first value, right, the first index inside our max window is earlier. So we're not current element is not in our sliding window. So we say I minus window size like this. Then we need to pop it off from the left side. So pop left like this. Cool. And then we can print the values back. So running this, we should see 2, 2, and 1. Right? And if we add 7, we should see 2, 2, 1, and 7. And we need to save it. And we do. Awesome. Cool. So this solution, let's talk about time space complexity. So we're going through every element inside an array. So the runtime would be of n. And for space, we're just building our window, so it can be of w for space like this. Yep, cool. Let's just for fun, let's do the solution using heaps. So for this, we'll need to import heap q, or let's do from heap q import. So we need push, heap, and heap pop. Yes, cool. So underlying data structure for heaps, it's just a list. So we have this. And again, like in the previous solution, we need to construct the first window. So for I in range window size, we need to push the value. So heap push. The first argument is h, and what we will be, because we'll the heap q uses min heap, and we need to construct max heap. What we'll be pushing is tuple. The first value would be so the a of I, and we need to convert it to negative value like this. So the heap becomes max heap, and the other value we need is I, so that we know if the current max inside window is actually within our sliding window, right? So after we're done, we can just print h, the first value, and the first value inside tuple, and we need to convert it back to get the actual value. If we print this, we should get 2 back. And we do. This is great. The rest for I in range. We need to go over each element, and we'll be pushing values and printing them like this. But we need to check, so while the current values index is less than, so window size. So this line right here is just checking, okay, we have our max, the root is always max, right? But we need to check if it's within bounds of our sliding window. If it's not, we can just heap pop like this, right? If we clear the output and run it, we should get 2 to 1. And we do. Let's work for other functions like this. And it does. Awesome. Cool. So for runtime, we could say that this is of n. And because we're pushing and popping and checking, we could say log w or log n in the worst case for time. And for space, we're constructing our heap, which would say of w or of n, right, for space. Cool. Yeah, That's it for this solution. If you have any other ways of solving this problem, please leave it in the comments below. And that's it for this one. Have a good day and see you until next time. Bye.